Hello everyone, welcome to Science Solutions with Karishma. Today we are going to solve the chapter Rational and Irrational Numbers of Concise Mathematics Class 9. Before starting the chapter, let's see the different categories of numbers. Numbers are of two types, real and imaginary. And real number is further subdivided into rational and irrational numbers. Rational number is denoted by Q, and they are the numbers which can be expressed in the form of fractions P by Q, where P and Q are integers and Q is not equals to 0. So for example, 1, 2, 3, 0, negative numbers, -1, -2, and so on. And they can be root over 2, root over 4, and they can be cube roots. And irrational numbers are neither terminating nor recurring decimals, and they cannot be expressed in the form of P by Q. For example, root over 2, the value is 1.414. The 414 is neither terminating nor recurring. And another example of irrational number is pi, 22 by 7. It is also an irrational. Rational numbers are of two types, integers and fractions. Integers are any normal numbers. They can be positive, 0, or negative. The numbers which includes 0 and positive numbers, they are called the whole numbers, denoted by W, starting from 0, 1, 2, 3, and so on. And the numbers excluding 0 are called the natural numbers, denoted by N. For example, 1, 2, 3, and so on. So the whole numbers includes 0, while the natural numbers does not include 0. And the natural numbers are further subdivided into many categories. Some of them are odd, even, prime, composite, etc. So the first question is 0 a rational number? Can it be written in the form P by Q? So, yes, it is a rational number, because it comes under whole number, which is a rational number and can be written in the form P by Q. That is, 0 can be written as 0 by 1, like P by Q, where Q is not equals to 0. So yes, 0 is a rational number. Next question, are the following statements true or false? Give reasons for your answer. Number 1, every whole number is a natural number. You have to show that every whole number can be a natural number. It's false, because 0 comes under whole number, but it is not a natural number. Let me show you that rational numbers are of two types. The positive and the 0 comes under the whole number, starting from 0, 1, 2, and so on. These are the whole numbers. And the positive numbers, which does not include 0, they are the natural numbers. So 0 is a whole number but not a natural number. Next, every whole number is a rational number. It's true, because the whole number can be written in the form P by Q, and it comes under the rational number. Next, every integer is a rational number. It's true, because integer can also be written in the form P by Q. So it's true. Next one, every rational number is a whole number. That's false, because every rational number may or may not be a whole number. The rational numbers include numbers from 0, 1, 2, and so on, and also negative numbers like -1, -2, and so on. So let us consider some rational numbers, like let us consider them in fraction, like 1 by 4, 2 by 4, 4 by 4, etc. If you consider 4 by 4, you'll have the answer 1. So it is a whole number. Okay, it is a rational number and it is a whole number. And if you consider 2 by 4, you'll have the answer in decimals 0.5. It is not a whole number. So every rational number is not always a whole number, but every whole number is a rational number. Keep that in mind. Next question. Arrange -5 by 9, 7 by 12, -2 by 3, and 11 by 18 in ascending order of their magnitudes. Here we have to find the ascending order of these numbers and also find the differences between the largest and the smallest of these rational numbers. Express these differences as a decimal fraction correct to one decimal place. So here we have to find the answer in the decimal fraction correct to one decimal place. So let's do it. Take this number -5 by 9, 7 by 12, -2 by 3, and 11 by 18. Now what we have to do is we have to find the LCM of the denominators. So the LCM of 9, 12, 3, and 18 will be 3 3 is a 9, 3 4 is a 12, 3 1 is a 3, 3 6 is a 18, 3 1 is a 3, 4, 2, 2 2 is a 4, 2 1 is a 2, 2 1 is a 2. So 3 3 is a 9, 9 2 is a 18, 18 2 is a 36. So 36 is the LCM. Now what we have to do is we have to multiply the denominators to make 36 in the denominator. So we will do multiply 9 by 4. So 9 4s is 36. So on the numerator we'll multiply with the same number 4. Next 12 into 3 is a 36. So we'll multiply by 3 minus 2 by 3. 3 12s are 36, so we'll multiply by 12, and 18 2s are 36, so we'll multiply by 2. So here we will get minus 20 by 36, 21 by 36, minus 24 by 36, and 22 by 36. Now we have to arrange these numbers in ascending order. So first we have to find the smallest, then the largest. So among these numbers, the smallest number would be, because of the negative sign, minus 24 would be smaller than minus 20. So here, out of two negative numbers, the smallest would be minus 24 by 36, and then after that it will be minus 20 by 36, and out of these two positive numbers, and 21 will be the smallest and 22 will be the largest. So arrange them. So first will be minus 24 by 36, then 20 by minus 20 by 36, then 21 by 36, then 22 by 36. Or the answer is minus 2 by 3, minus 5 by 9, 7 by 12, and 11 by 18. So this is the ascending order of these numbers. Now we have to find the differences between the largest and the smallest of the above numbers. So the difference between the largest and the smallest would be between the largest and smallest. So the largest here is 11 by 18 and the smallest is minus 2 by 3. So after calculating, you'll get 11 by 18 plus 2 by 3. Here in the denominator, we have multiplied 3 by 6 to make it 18, to make it easier to calculate. So here we get 12 by 18, and after that we'll get 11 plus 12, you'll get 23 by 18. Now in question it has been asked to find the answer in decimal correct to one decimal place. For that we need to divide 23 by 18. So when we divide 23 by 18, we have to find the answer correct to one decimal place. So we get 18 1 ja 18, you'll have the remainder 5, 1 decimal, then 0, then 18 2 is a 36. You'll have the 4 remainder here and then 1 remainder. Again add 1 0, 7. You'll get 126 and then the remainder will again be 14, and if you'll add 1 0, it will be 7 again, and it will be recurring. 7 will come again and again. That means it is recurring. So for recurring, we'll mark 7. So your answer will be 1.27 recurring. 1.27 recurring. But this answer is in 2 decimal places. So for answer we have to find 1 decimal places. So 1.27 is nearly equal to 1.3. So the answer is 1.3 because it is correct to 1 decimal place. So in this way we have to find 1 decimal place answer. In case of 1.27, after the decimal there are 2 numbers, 2 and 7, that is 2 decimal place. In 1.3, after the decimal there is 1 number, so it is 1 decimal place. Next, arrange 5 by 8 minus 3 by 16 minus 1 by 4 and 17 by 32 in descending order of their magnitudes. So we have to find here the descending order, and also we have to find the sum of the lowest and the largest of these fractions, and the answer would be in correct to 2 decimal places. So here we have to find 2 decimal places. Okay, so let's get started. Consider this number 5 by 8 minus 3 by 16 minus 1 by 4 and 17 by 32. Again the same, we have to find the LCM of the denominator. So the LCM of 8, 16, 4 and 32 would be 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 1s are 2, 2 6s are 12. Again by 2, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 8s are 16. 2 1 2, 2 2 4, 2 4 8, 2 1 2, 2 2 4. So your answer will be 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So LCM is 32. Now you have to make 32 in the denominator by multiplying. So in order to make 32 in the denominator, we will use a number, and by the same number we will multiply in the numerator also. So in order to make 32, we'll multiply 8 by 4. So here we'll get 5 by 8 into 4. 4 8 is 32, and we'll again multiply by 4 in the numerator. Same like that, we'll multiply 16 by 2 minus 1 by 4, we'll multiply 4 by 8, and 17 by 32. 32 into 1 is 32, so we'll multiply by 1 in the numerator also. Now we'll have 20 by 32 minus 6 by 32 minus 8 by 32 and 17 by 32. So now we have to arrange these numbers in descending order. So for descending order, we have to find first the largest number, and then we have to arrange them in descending order. So the largest number here is 20 by 32, and then 17 by 32, and then 8 by 32, and minus 8 by 32, and then 6 by 32. So out of these two negative numbers, minus 8 is the smallest, so first 8 will come. So arrange them in descending order. So let us arrange these numbers according to the descending order of their magnitudes. So here we have first 20 by 32, then 17 by 32, then minus 8 by 32, and then minus 6 by 32. Or we'll have 5 by 8, 17 by 32, minus 3 by 16, and minus 1 by 4. So this is their descending order. Now we have to find the sum of the largest and the smallest number. Sorry, not the difference, but the sum. Sum of 5 by 8 and 1 by 4. 5 by 8 plus, now the difference, it's the sum. So we'll have the sum of 5 by 8 plus minus 1 by 4. We'll get 5 by 8 plus into minus is minus 1 by 4. So we'll make the denominator 8. So for making this, we have to multiply 4 by 2, and again by 2 we'll multiply the numerator. So 5 by 8 minus 1 by 4 into 2, again we'll multiply by 2 over here. We'll get 5 by 8 minus 2 by 8. We'll have 5 minus 2. It will be 3 by 8. Again, we have to find the answer in decimals in correct 2 decimal places. So for that, we need to divide 3 by 8. So when we divide it by 8, we'll have 0.3. It will be 24, and the remainder will be 6, and 7, 56. Then we'll have the remainder 4, again 0, then 5, 40. So it is terminating decimal. So the answer will be 0.75. So in answer, we have to find corrected two decimal places. That means after decimal, there will be only two numbers. So our answer will be 0.38 because 5 is nearly equal to 8. So it is the answer in two decimal places. So that's all in this video. I hope you all understood. And in the next video, we are going to solve the other half of the exercise 1A, starting from question number 5. And if you like the video, please like, share, and subscribe to my channel.